is Unit 8, Lesson C, Solving System of Equations by Substitution. After this lesson, you will be able to find the solution to a system of linear equations by using the substitution method. Yesterday, we were learning about the graphing method, where we graph two lines to see where they cross in order to find the solution. Today, we're going to be focused on algebraically solving the equations in order to find the point where they cross. The steps to solving a system of linear equations using substitution. Solve one equation for x or y. It means you need to get a variable by itself, alone. Sometimes the variable will already be alone, but sometimes it's not. So you've got to make that decision whether you have to solve or not. Then you're going to plug in the equation from step 1 into the other equation. And this is where you should end up with one variable. So all these equations are going to be x's and y's, but when you substitute, you should only have one variable. And again, this step is what we would call substitution. This is when you substitute in one value for the other. Substitute. Then we are solving for the variable in the equation, the only variable that's in the equation. Once you have it, plug your answer from step 3 into the original equation and solve for the remaining variable. All of our answers are going to be ordered pairs, just like it was yesterday, where we have an x and a y coordinate value. We're going to take a look at example 1 first. Step 1 tells us we need to decide if there's a variable by itself on one side of the equal sign. Well, here, x is by itself. This y is next to a 5. This y is next to this 2x. This x is next to this y. The only one that's by itself is the x I circled. So I'm going to take everything that x equals, and I'm going to plug it in to the second equation. Here's where substituting happens. 2 is the coefficient, so I write that. It's multiplying. I put a space because that's where I'm going to substitute. But I'm going to finish writing everything else first. The most common mistake people make when substituting is they forget to write the entire equation. So I write it before I actually plug in. This 5 plus 2y is what's going to plug in right here. Whenever you have something on the outside of a parentheses, that means to distribute by multiplying each term inside the parentheses. 2 times 5 is 10. 2 times y is positive 2y. We're then going to drop everything else. Plus y equals 25. I'm trying to get my variable by itself. Notice I only have y terms, which means I substituted correctly. You should only have one variable. And they're on the same side of the equal sign, so I'm going to combine them together to get a 3y, positive 3y. Everything else drops down. You get your 10 equal 25. We're now supposed to solve for the variable that remains. That's step 3. Before we divide, we got to get rid of that constant. Subtract 10. 3y equals 15. Now we can divide. Y equals 5. But that's only half of our answer. So I've got to take this y equals 5, and I got to plug it back into the original equation up top. X equals 5 plus y. Well, we just said that y is what we solved for, which is 5. Now that I know that it's 5, I know x equals 10. My final answer is an ordered pair, which is always x and then y. My x is 10, my y is 5. So the solution to this system of equations is 10, 5. Notice if I had graphed that, that would be really, really far up. Here is where they cross. So sometimes solving it algebraically can be a bit of a shortcut if it would take too long to graph. Again, where those two lines would cross would be at 10, 5. Pause the video now as you try example 2. Press play to go over your answer. Make sure you're actually pausing and trying. That's how you learn. We're looking for a variable to be by itself, which is y. It equals x plus 1, so that's what we're plugging in for y. I rewrite the other equation, 2x plus, I'm plugging in for the y, equals negative 2. Again, make sure you don't forget any of the details. We're plugging in x plus 1. There's only a 1 out in front, so technically when I multiply it, nothing's going to change. But I do want to drop everything else down. I'm trying to solve for my one variable. I only have x terms, so that means I substituted correctly. Combining those together, I get 3x because they're on the same side of the equal sign. 1 equals -2. Subtract the 1. 3x equals -3. Divide by 3. X equals -1. Now that I have that, I know I have to get the second half of it. I'm going to plug it in. Pause the video now if you have not already plugged it in to try and see what you get for y. Y equals x plus 1. We were just told that x is -1 from our solving. So y equals -1 plus 1, which is 0. So our answer, which is always in x and y order, my x is -1, my y is 0. Those two lines would cross at the point -1, 0. Pause the video now as you try this example 3. Press play to go over your answer. Now, the only thing that's kind of crazy about example 3 is that you have two variables that are by itself. So I'm just going to pick the top one, and I'm going to plug it in for the bottom one. Again, make sure you've paused the video to try this on your own. -3x plus 5 equals 2x minus 10. All I've really done is take those two parts of the equations and set them equal. I know I did it right because I only have an x variable, but they're on opposite sides. So to avoid a negative, I'm going to pick on the little guy. We could have picked on either one, but I like avoiding negatives. So this drops, this cancels, equals 2x plus 3x is 5x minus 10. Finish my solving skills, trying to get x by itself, so I have to add my constant. 15 equals 5x. Divide both sides by 5. X equals 3. Since that's only half my answer, I'm going to take this, and I'm just going to plug it into the top equation. It doesn't make a difference which one you plugged it into. Y equals -3. We're replacing x plus 5. We're plugging in a 3. Y equals, well, these are multiplying. -3 times 3 is -9. We drop our 5 down. So that means y equals -9 plus 5, which is -4. For our final answer, we know we have an ordered pair. We know x is 3. We know y is -4. If your answer is not written as an ordered pair, it would not be correct. Again, that's where the two lines cross on a graph. Pause the video now as you try example 4. Press play to go over your answer. What you might have noticed is a little challenging on example 4 is we don't have a variable that's by itself. I could either pick y or x and solve for it to be by itself. So I'm going to pick this y, which means I need to get that 2x to go to the other side. So now it reads y equals -2x plus 6. Since that's what y equals, I'm going to take it and I'm going to plug it in for y. The equation on the bottom is x minus 2. I'm replacing the y equals 3. Make sure, again, you have all of those pieces because that's what people forget the most. This is -2x plus 6. Whenever we have parentheses, that tells us to distribute. -2 times -2x is positive 4x. -2 times positive 6 is -12. And we're going to drop down our x equals 3. I'm got one variable, which means I substituted correctly. 1x plus 4x is 5x. Drop the -12 and drop the 3. We're trying to get x all by itself, so we add 12 to both sides. So we get 5x equals 15, x equals 3. That's only half my answer, so I take it and I plug it in to the top equation. Y equals -2, parentheses, times 3, that's what we just solved for, plus 6. Y equals -6 plus 6. Well, -6 plus 6 is 0, so y equals 0. Remember, your answer has to be an ordered pair, x first, then y. So where those two lines would cross would be at the point 3, 0. Pause the video now as you try example 5. Press play to go over your answer. Make sure you're pausing it. Don't just wait for me to start talking. Make sure you paused it. So the trickiest part here is that I've got to be able to get a variable by itself. the one that's the closest is this negative y. So I'm going to start solving that one for y. I get negative y equals negative 2x plus 3. Now, we know a negative y is actually negative 1 times y. So we're going to divide by it to get rid of it. So y equals a negative and a negative make a positive 2. X, positive and a negative make a negative 3. So now that I have y by itself, I'm going to take everything that y equals and plug it in to the other equation. Negative 3x plus 2, leave a space for your substitution, equals 6. We're substituting in 2x minus 3. That's what we got when we solved for y by itself. Now, whenever you have something out front, you always have to distribute. 2 multiplied in there gives you positive 4x minus 6 equals 6. And we also drop the negative 3x down. Don't forget about that guy. I'm trying to solve for my one variable. That's how I know I substituted correctly. Negative 3x plus 4x is 1x minus 6 equals 6. X, we're going to add 6 to both sides, equals 12. But that's not our whole answer. We need to take that and we need to plug it in to be able to find out. I'm going to plug it into right here, actually. Y equals 2. We got 12, positive 12, minus 3. 2 times 12 is 24, minus 3 is 21. Again, my answer must be an ordered pair. So I do my x value first, followed by my y value. So these two lines would cross at the point 12, 21. That's another really good example where graphing 12, 21 is way up in the first quadrant. So we wanted to use a shortcut by using substitution method. Pause the video now as you try example 6. Press play to go over your answer. Again, it's a situation where they're both solved, so I'm just going to pick one at the top and plug it to the bottom. Negative y plus 15 equals negative y minus 17. Well, this looks kind of funny. My y's are on opposite sides, so I'm going to pick on one of them. But what I notice is that they both cancel. So I'm left with 15 on this side is equal to negative 17. Is that true? No, it's not true. So that means there is no solution. And if you think about it for a second, what kind of lines have no solution? Parallel, perpendicular, coincident, or IB and P? Hopefully you were thinking parallel lines. Parallel lines never cross. And they never cross because they have the same slope. We'll take a look. The slope here is negative 1. The slope here is also negative 1. So right from the very beginning, you could have seen they're parallel, so they would have no solution. And of course, the way we see it algebraically, if you get a number equal to a number and it's not true, that's how you know that it is parallel, no solution. Pause the video now as you try example 7. Press play to go over your answer. So I'm going to take this guy, and I'm going to plug him in here. 4x plus 2, leave a big space, equals 6. I'm going to write negative 2x plus 3, because that's what y equals. Distribute the 2. Negative 4x plus 6 equals 6. Drop the other 4x down. These are on the same side. 4x minus x, oh, they cancel. So I get 6 equals 6, which is true, which means that there are infinite solutions. And the reason why we have infinite solutions, think about what kind of line has infinite solutions: parallel, coincident, perpendicular, IB and P. They are coincident. And that means they're the exact same line. Now watch this. I'm going to solve this for y. 2y equals negative 4x plus 6. Divide by 2. Y equals negative 2x plus 3. What do you notice about those two lines? They're exactly the same. So that's why they're coincident. If they were a graph, they'd be right on top of each other, so there's infinite solutions. Algebraically, we knew it because we got 6 to equal 6. A number equal to a number is true. That's why it is coincident. This is the end of our video. Go ahead and begin working on the worksheet. If you have any questions, raise your hand and have a wonderful day.